If you could see the universe with X-ray eyes, you'd uncover hidden engines, colossal shocks, and jets that pierce through galaxies. Today, we'll walk through 25 Chandra images, a direct Knopfler tour, what each scene is and why it matters. Get ready. The high-energy cosmos is far more alive than it looks. Crab Nebula M1, remnant of a supernova recorded in 1054. At the center, a pulsar, a neutron star spinning dozens of times per second, injects relativistic particles. The rings and stem are shock waves and jets from the pulsar wind. In X-rays, we see where the magnetic field accelerates electrons to absurd energies nursery in Orion, a field with dozens of young stars, many Tauri types. In X-rays, these stars show magnetic flares that heat their corona to millions of degrees. Shocks from jets and winds sculpt the cloud, interfering with planet formation in the disks around them. The eyes NGC 4438 and NGC 4435, a galaxy pair intacting in the Virgo cluster. The X-ray halo reveals hot gas stripped by tides and by the wind of the intracluster medium ram pressure. This process dries out galaxies, reduces star formation, and redistributes matter into the cluster environment. Cat's Paw Nebula, NGC 6334, a massive nursery in the Milky Way. The X-ray sources are newborn stars hidden in dust. Winds and radiation from the most massive ones create bubbles and shock fronts in H2 regions, regulating how many new stars will still form there. Center of the Milky Way. A carpet of hot gas and non-thermal filaments crossing the region of the black hole Sagittarius A star. The filament indicate organized magnetic fields and particle acceleration. Zones like Sagittarius C combine star formation, remnants, and turbulence. Pillars of creation M16. Columns of gas and dust sheltering protoirs. The X-ray sources mark young, already energetic stars. Along the edges, radiation from massive stars photo-evaporates material, both triggering new collapses and eroding protoplanetary disks. Bat Shadow. A proto with its disk-seen edge on cast a bat-shaped shadow onto the clouds behind it. Variations in the shadow reveal distortions in the disk, clues to the architecture where planets are forming. In X-rays, we see the young star's magnetic activity. NGC 7469, a spiral galaxy with an active galactic nucleus, AGN, and a star-forming ring. The bright X-ray center is superheated gas in the black hole's disk corona. The same region that feeds the AGN receives gas from the ring and returns energy through hot winds. M86 with tail. A galaxy crossing the Virgo cluster at approximately 1,200 kilometers per second. The X-ray tail is gas from M86 itself being stripped by the cluster's hot medium. The result? Loss of cold fuel and a drop in star formation. The lost gas enriches the environment. WR124 Wolf-Rayet star. A massive star in an extreme mass loss phase. Supersonic winds collide with previously ejected material and heat the gas to millions of degrees. X-ray emission. These pre-supernova stars forge heavy elements and blow dust into the interstellar medium. PWN plus supernova remnant. A central pulsar and its synchrotron wind nebula enclosed by the supernova remnant's cocoon. Forward and reverse shocks compress and heat the interior. It's a laboratory for understanding cosmic ray acceleration. Centaurus A, a galaxy with a dust lane and relativistic jets from the central black hole. Chandra maps the jets and X-rays and the bubbles inflated in the halo. Evidence of AGN feedback that can heat gas and affect star formation. Cassiopeia A, young remnant, approximately 350 years of expansion from our point of view. In X-rays, arcs and filaments rich in silicon, sulfur, calcium, iron show the mixing of the star's inner layers. The explosion is asymmetric. Shocks accelerate particles to high energies. NGC 3532, a nearby open cluster. X-rays highlight stars with active corona and fast rotation. Useful for studying how magnetic activity declines with age and how X UV radiation impacts exoplanet atmospheres. NGC 6872 and IC 4970. Gravitational interaction stretches the arms of the giant spiral NGC 6872. In X-rays, shocks and starburst regions appear. Some gas is captured by the smaller companion IC 4970, possibly feeding its central black hole. Planetary nebula HB5, a sun-like star at the end of its life. A fast wind slams into the earlier slow wind, heating gas, X-rays. The bipolar shape suggests columnated jets and or the influence of a binary companion. Radio shows cold molecular gas coexisting with hot gas. Able 2125 cluster. A sea of galaxies immersed in intracluster gas at tens of millions of degrees. The X-ray patches reveal subclusters in the process of merging, the largest shocks in the present-day universe, and let us study dark matter and the gas's thermal history. Star formation bubble double cluster, a shell blown by winds and radiation from massive stars. The interior fills with hot gas, X-rays, while the compressed rim favors new collapses. Two clusters at the center suggest sequential formation. NGC 1365. A barred spiral with a central AGN and several X-ray binaries scattered around the compact objects. Black holes are neutron stars trace recent star formation. The X-ray nucleus probes fueling and variability of the supermassive black hole. Hand of God. PSRB 1509-58, a pulsar and wind nebula with a hand-like morphology. In X-rays, the glow is synchrotron emission from particles accelerated by the pulsar. Near the fingertips, a cloud of softer X-rays where the wind impacts nearby gas. ARP220, a merger between two Milky Way-sized galaxies. Beneath thick dust, there's an extreme starburst and possibly AGNs. The pinkish X-ray halo is a superwind created by thousands of supernova carrying energy and metals out of the core. Jupiter X-ray auroras. The polar bands in X-rays are auroras caused by energetic particles guided by Jupiter's magnetic field powered by the solar wind and Io's torus. Unlike Earth, Jupiter keeps nearly continuous, much more energetic auroras. Double cluster in the LMC. Two young clusters in a satellite galaxy of the Milky Way. X-ray sources include high-mass binaries and small remnants. The large blue filament is a shock front swept up by stellar winds and recent supernova. Max J0035 cluster. The golden dots are galaxies. The X-ray haze is super-hot intracluster gas. By mapping the X-ray brightness, we measure the cluster's mass and structure, inferring dark matter and the history of mergers. SN1 1987A. The closest supernova observed in the modern era in the Large Magellanic Cloud. The equatorial ring, material ejected before the explosion, is being struck by the shock wave, producing X-rays. Inside are hot debris and signs of a newly born compact object. In 25 frames, we've seen matter's full cycle. Clouds that collapse. Stars that blow winds explode and seed metals. Black holes that return energy through jets and outflows. Galaxies that meet in clusters that merge. X-rays are the chemical and thermal marker of these processes. They show where energy is being injected and how it dissipates. Without them, we'd miss most of the physics that truly stays a universe. Shocks, magnetic fields, ultra-hot plasmas, relativistic particles. Did you like this straight-to-the-point trip? Hit like, subscribe, and turn on notifications so you don't miss what's next. Which of these images should get a deep dive solo video? Drop a comment below, and I'll bring you the behind the scenes in detail.